In this video, I'll be working through some examples from the worksheet that's posted on Canvas. So a good idea, again, once again, is to print off the worksheet, work on it, watch the video, kind of flip back and forth and check yourself so you don't wreck yourself. So here's y equals 2 cosine x. So first thing I notice is the only different thing, this is a cosine curve except for it's got a 2 out front. Remember, in this case, 2 is the amplitude, which is the distance from the middle to the top. We also refer to it as the stretch factor. So that means that I'm going to have a normal cosine curve in all aspects except for the top. Top is going to be higher and the bottom is going to be lower. So the middle will still be centered on the x-axis, but it's going to go up to 2. So I'm going to put a little dotted line up here at 2. It's going to go down to -2. So put a little dotted line down here at -2. And there's pi over 2. There's pi, 3 pi over 2, and 2 pi, and maybe a 5 pi over 2 there. So notice that this is about 1.7-ish, so it should be longer than that, but not as long as that. Okay, so now I'm going to go ahead and draw. Cosine starts at the top. I need to use a different color, just so we can see the difference. Maybe we'll use blue. So cosine starts at the top, but notice it's starting at 2, not at 1. It's going to go down to the middle, which is 0. And go down to the bottom, which is -2. Back up to 0. Back up to the top. Oops. Notice the spacing from top to middle and from middle to bottom is the same distance on the x-axis. That's that spacing that we've talked about before. Okay. Now how's different here? Notice here the 2's on the inside, and also this is a sine curve. But so let's once again draw a little axis here. There's 1, there's 2, there's 1, 2, 3. So that's pi, that's 2 pi, etc. So now this 2 is what we call frequency. And so remember that period is equal to 2 pi divided by frequency, which means my new period is going to be pi. So that means this is a sine curve that's going to complete itself by the time it gets to pi. So what does the sine curve look like? It starts at the middle, which would be right here, and it ends at the middle. So that's where it ends, at pi. Halfway through the cycle, it's at the middle. So put a little dot right here. And between these two, halfway between these two, it's at the top. Halfway between the next two, it's at the bottom. And you can see this, of course, just keeps going. And there we go. Remember, when you're drawing a curve, you always want to do one full cycle and a little bit more on either side. So probably should go down to here, right? Okay. Now, secant, I've said many times when I'm teaching trigonometry that the key to trigonometry is to know sine and cosine really well, because we know that this is the same thing as 1 over cosine 2x, right? So knowing that, what I'm going to do is draw cosine first and then just get secant from that. So just like I did in the video when we talked about secant curves. So if I go, let's see, here's my 1, and there's my -1, there's my pi over 2, my pi, my 3 pi over 2, my 2 pi, and pi. So first thing I'm going to do is draw a cosine curve. So I'm thinking y equals cosine 2x. What does that look like? It's a cosine curve with the frequency equal to 2, which means period is equal to 2 pi divided by 2, which is just pi. So that means I want a cosine curve that starts at 0. The first cycle starts at 0 and ends at pi. So that means it's going to start right there, end right there. Halfway through, it's going to be down there at the bottom. And it's going to cross the middle right in between those two. So I'm going to put a dotted line, because this is not my actual graph, right? There we go. That's the cosine curve, which I'm not actually drawing. I'm drawing secant, but this helps me give a reference, because I know whenever cosine 0 or actually whenever cosine's in the middle, secant is undefined. So that means I'm going to have an asymptote right there, right there, right there, right there, right there, etc. I also know that whenever cosine is 1, secant is also 1. Or whenever cosine's at the top, secant also is at the top. So that means now I'm going to change color because I'm actually going to draw the secant curve. That's what I really wanted is secant's got to be right there, right there, right there, and right there. And remember, as I get close to the asymptote, there's only one type of behavior can happen. It shoots to the space, shoots up. Here it's going to shoot down because it can't cross there. Here it's going to shoot up, shoot up. There it's going to shoot down, etc. That's secant. And so you can see the key to graphing secant is just getting a picture of the cosine. So likewise here, since I have cosecant, that means I'm going to start with sine in my mind's eye. So I'm really going to start out by graphing 3 sine 2x. So here we go. I'm going to have to go up to 1, 2, 3, down to 1, 2, 3, negative 3 and 3. And I'm going to go out to, there's a 2 pi out there. So this has an amplitude of 3, which means it's going to start there. The top will be at 3 because there's no vertical shift. The bottom will be at negative 3, right? And the middle will be right there at the x-axis. What does the 2 tells me? The 2 tells me that the period is equal to 2 pi divided by 2, which means pi, right? So this sine curve is going to complete one cycle by the time I get to pi. So that means I'm going to start right there, and I'm going to end right there, and I'm going to hit right there. In the meantime, I'm going to go up to the top, back down to the bottom, back up, top, middle, bottom, middle, etc. And when sine is at the middle, secant is undefined. So I got a nice vertical asymptote right there. Nice vertical asymptote on the y-axis. Nice vertical asymptote right there. Nice vertical asymptote right there. A whole bunch of vertical asymptotes. Here a vertical asymptote. There a vertical asymptote. Everywhere vertical. Well, not everywhere actually. So then when I go to graph now I'm going to go back and tune in. Oh yeah, I'm supposed to graph cosecant. So cosecant is going to hit right there and go up. Come down and hit there and go up. Come down here and hit and go back up, etc. Whoops, sorry about that. You can see this right here. I got a little bit sloppy here. Shouldn't hit the asymptote, right? These should be nice rounded curve, kind of parabola looking things. Okay, there's some good examples. Let's see, let me do one with a phase shift real quick here. We'll take this sine right here. So here's my curve, the phase shift to pi over 2. So these have 2 shifts. It has a phase shift and a vertical shift, so that'll be good because we haven't done either one of those yet. There's a 2 pi. There's a pi. So the plus 1 means I have a new middle, so I'm just going to put that in. The amplitude is 1, so I'm going to put a dotted line there. Amplitude is 1, so I put a bottom. So this is my bottom, this is my top, middle, and this is my top, right? And it's a sine curve. The frequency is 1, which means the period is a normal 2 pi. And so that means that its sine's going to start at the middle. It's going to, here, let me give it a different color. Let's go with red. I love red. It's going to start at the middle, it's going to end at the middle, and it's going to be at the middle halfway through the cycle. Right? That's normal. But since I have a phase shift here, that means that those things are going to be moving, and since it's minus pi over 2, we're going to move them pi over 2 to the right. So instead of starting here, I'm going to start right there. So I can erase that little, oops, I was afraid of that. Okay, and maybe I'll just change colors so we don't have to erase I'll change it to orange. So the new place is going to be right here. This guy's going to hop pi over 2 to the right there. This guy's going to hop pi over 2 to the right there. So I'm looking at the orange things instead of the red things. So sine's going to start at the bottom, or at the middle, I mean. Go up to the top, back down to the middle, down, whoops, down to the bottom, back up, etc. Okay. And so you can see, once again, if I pull out a highlighter, you can see that the first cycle. See, it's right here. Whoops. I'm messing up here. Sorry about this, guys. What I meant to do is do a highlighter. I'll use a different color, like green. So you can see that bit right there. That's the full cycle. And you can see it did start originally over here without the phase shift and would have ended right there. But because of the phase shift, it starts pi over 2 to the right and goes from there. Okay, and notice that the normal signs, the top is 1, but because of that +1 shift, it moves up to 2. And normally the bottom of sine is -1, but because of that vertical shift, it moved up to 0. And also the middle is normally on the x-axis, so the +1 moved it up to y = 1. So that's a good start. I'd recommend you trying some of these. Send me questions about if you're having trouble, something like that. And I'm also going to send out an email, but on the homework questions 13 through 16, parts C and E are broken, meaning that it's not correct. It's not accepting answers correctly. So when you do the homework, you can do 13 through 16, but just don't bother with parts C and E. And when they get fixed, hopefully they'll fix it. I've talked to people at XYZ. They're working on fixing it, but I don't know if it will get fixed. So don't worry about doing those parts. We'll figure out. I'll give you the points in the end if we can't get it fixed. All right. Let me know if you have any questions.